Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears. The antennae of a butterfly, which up close look like feathers. The snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever manage to stay on top of the food chain. Animal super senses. You won't believe what's possible. Welcome to Animal Super Senses, the show that plugs you in to how animals experience the world, often with sharper and more evolved senses than the one species who likes to think of itself as the top of the food chain. That would be us, of course. While all life began in the oceans, human beings now rely on technology to navigate the seven seas, left to our own devices. We're like the proverbial fish out of water, only the other way around. Once underwater, with light diminished, our vision becomes blurred, our hearing becomes muffled and distorted, and our sense of smell is rendered completely useless. Now compare that, for example, to that renowned predator, the great white shark. This elegant killing machine is perfectly attuned to every sight, sound, scent, chemical, and electrical signal of its marine environment. We'll pay a slightly nervous visit to the great white a little later in the episode. But first, listening carefully? Because the sense of hearing enters a whole nother dimension when applied to creatures of the deep. Hearing is critical for animals such as the sperm or humpback whale. For one thing, light fractures and weakens underwater, so vision becomes a less important tool for survival. Sound, however, travels further in the water than in the air, so for whales it's critically important as a way of communicating, most famously as in the song of the humpback whale. Humpback whales are members of the cetacean family, which includes whales, dolphins, and porpoises, all of which have well-developed senses of hearing. In the case of this humpback whale, its outer ear is a very small opening that closes once underwater. Instead, it picks up on waterborne vibrations through bones in its head. Good vibrations that ultimately reach its middle and inner ears. Fascinatingly, the ancestors of the whale actually walked on land. Pakistanidae, or Pakistani whales, lived on the shores of the Indian subcontinent and began to diversify, making for the water some 53 million years ago, give or take. More about them and their ancestors later in the show. Meanwhile, to be a little bit more specific about what hearing is, it's the ability to sense sonic vibrations. Sound and what is known as vibrational stimuli, they pretty much amount to the same thing underwater. The scene now is the Coral Triangle. This is the area of tropical marine waters around Malaysia, the Philippines, Indonesia, and East Timor. A tropical paradise in many regards, sometimes known as the Amazon of the seas. But one that the World Wildlife Foundation is keeping a close eye on to ensure human activity doesn't spoil this particular paradise too. Among the countless species that call the Coral Triangle home, you'll find plenty of cephalopods. Plenty of what? Cephalopods, like cuttlefish and this octopus, are invertebrate, spineless mollusks with generally large heads and symmetrical bodies. For over a century, there's been a debate as to whether these creatures are capable of hearing. But the consensus seems now to be that they can, either by something called the statocyst organ, a fluid-filled sac lined with sensory hairs that also helps them to maintain balance, or they can hear via lateral lines, similar to that found in fish, visible lines on the fish's body comprised of sense organs which detect pressures and vibrations. Now, of course, there are more fish than you can shake a million fish sticks at in the Coral Triangle, and chances are they'd hear you when you shook those sticks at them. Because as any goldfish owner can tell you, at any kind of threatening sound, a fish will curl into a tight C shape and head in the opposite direction. So whether in a goldfish bowl or the Coral Triangle, we know that fish can hear, but believe it or not, scientists are somewhat divided as to how. Here are the two main theories. The bodies of fish have about the same density as water, which means that sound passes through their bodies. But fish have bones in their inner ear, which are called otoliths. These bones are denser than both the water and the fish's body. This means these bones move at a slower pace than the rest of the fish's body, and also the speed of the sound waves. The upshot of this is that the difference in speed between the otolith bones and the rest of the fish's body ruffles the hairy sensor cells located in its inner ear. This differential movement is interrupted by the brain as sound. Then there are the lateral lines we mentioned before. These are essentially a set of tubes located just under the fish's, or in this case, the shark's body. Water enters these tubes through the pores of the skin. The tubes are lined with hair cells, which are connected in turn to sensory nerves. When anything gets close to a shark, the water running through the lateral lines moves to and fro. This stimulates the sensory cells, which alerts the animal to whatever prey or predators may be in the vicinity. When we talk about animal super senses, perhaps no animal fits the bill more than the shark. In the popular imagination, we imagine them, like this black-tip shark, moving stealthily through the water and then seizing their prey without mercy, relentless and unstoppable. And that's about the size of it. Their senses are also supremely well adjusted to make them effective underwater predators. For one thing, they have a particularly acute sense of smell. Unlike, for example, human beings, sharks have separate and distinct openings for breathing and for smelling. The gills on the side of their heads are for breathing only and serve to capture oxygen in the water. Meanwhile, two nostrils to the front of their heads hold water into a nasal chamber, specifically dedicated to detecting smells. Perhaps one reason a shark's nose works so well is because it doesn't have to do anything else. Breathing is accomplished with their gills, and a shark's sense of smell is not in any way connected to its mouth. But a shark's sensory arsenal doesn't end there. Sharks come with a unique sense organ as standard equipment, something called the ampullae of Lorenzini. They were first described back in the 17th century by one Stefano Lorenzini. They consist of small clusters of electrically sensitive receptor cells found just under the skin. These are connected to the water by pores on the shark's snout and head. What the ampullae of Lorenzini do for the shark is to outfit it with electroreception. In a nutshell, electroreception means the shark can sense the bioelectric fields generated by other animals and use it to locate them. And hey, you'd expect the ultimate predator to know where its next meal is coming from, right?